Hello friends, welcome to my channel. In this lecture, we will discuss about the off-wave rectifier and a full wave rectifier. First, let us see what is an off-wave rectifier. The off-wave rectifier is a circuit that converts only off of the input AC signal into a DC signal. So, it will convert only one of input signal into a DC signal. This shows the circuit of off-wave rectifier. This off-wave rectifier consists of three important components: a transformer, a diode, and a load resistor. Yes, if we observe a transformer, it is having two sections. We'll call this section towards the left hand side, it is a primary section, and this section towards the right hand side, it will call that has a secondary section. Primary section consists of the source voltage where we are getting 230 volts and 50 hertz. And in secondary section of the transformer, you can see the secondary section of the transformer consists of three terminals, but in a off-wave rectifier we are using only two terminals. You can see this is one terminal and this is another terminal. And in the primary section is having the term ratio as N1, and in secondary section is having the term ratio of the coil is N2. A diode is connected in series. A diode is connected in series with the load resistance. You can see it is connected in series with the load resistance, and the anode terminal of the diode is connected to one terminal of the secondary transformer, and the another terminal of the load resistance is connected to the secondary of the transformer. Yeah, now see here V2 is a voltage obtained at the secondary of the transformer, and this V2 is the input to the remaining part of the rectifier, right? So V1, now we will see about V1. V1 will be the source voltage, V2 will be the source voltage input to the rectifier. So we need to rectify voltage V2 to understand the operation of off-wave rectifier. Yes, we'll consider an AC signal. Now we'll consider an AC signal. Yeah, this is a AC signal graph. We have considered voltage V2. In this AC signal graph, we have considered a voltage V2. As you can see from the waveform, so we have considered voltage V2, which is the input to the rectifier, Now we will understand the working of off-wave rectifier. Yes, off-wave rectifier, and we will see how the circuits behaves when positive off of the cycle appear across the V2. Then we will see how the circuits behaves and the negative off of this cycle will appear across the V2. Yeah, now we will see during positive off of the input cycle. Let us consider positive off of input cycle. Yeah, see here. Yeah, this is the polarity is across V2. The polarity across V2. So at V2 there will be positive off of the input cycle and negative off of the input cycle. This is the positive and this is a negative, the polarity across the V2. Yeah, see here, the two terminals of V2 or two terminals of in secondary of the transformer will be a positive and a negative. It will be positive and it will be negative. Due to this polarity, diode D will be a forward bias. Because you can see anode is connected to the positive and cathode is connected to the negative polarity. That's why diode D will be a forward bias. Diode D will be a forward bias. Yeah, we know during forward bias diode will conduct a electric current. Diode will conduct a electric current. Yeah, diode will conduct a electric current. So current will flowing through the circuit. The current will flow through the circuit and we will get an output voltage is a V0. Output voltage is a V0. Okay. Now next, so the output voltage will appear across the load resistance. During, now in AC signal graph explanation, during positive of the input cycle will obtain a output which is equal to Vm. Now next, during negative of the input cycle, negative of will appear across V2. Now let us see negative of the input cycle. Negative of the input cycle will appear across V2. Yes, the polarity will be negative and a positive. Negative and a positive. Due to this polarity, you can see anode terminal of the diode is connected to the negative and cathode, and the cathode terminal is connected to the positive. Yes, so diode will be reverse bias. Diode will be a reverse bias. So we know during the reverse bias condition, the diode will not conduct, so we will not get any output voltage. So this process will continue in a graph. During positive of will get the output voltage, and during negative of will not get any output voltage. Yes, which means it is rectifying only off of the waveform. During negative of will not get any output voltage, and positive of will get a output voltage. This is a working of a rectifier. Yeah. Now let us see about V1. V1 can be written as Vm. V1 equal to Vm sin theta. Vm is a peak voltage. You can see Vm is a peak voltage, and V2 can be written as N2 by N1 into V1. Now N2 is a term ratio. Term ratio in a secondary of the transformer. N1 is a number of term ratio in primary of the transformer. Here the transformer will act as step down transformer if the number of term ratio is N1 is greater than N2. If this term ratio is greater than this, so N1 is greater than N2. At that case, the transformer will act as step down transformer. So if the term ratio of N2 is more than N1 is less, which means the secondary coil term ratio, which means the secondary coil term ratio is more than the primary coil. At that case, a transformer will act as step up transformer. Yes, we can write the equation of I. I equal to, I equal, yes, I equation. Now we can write the equation for I which will be produced during positive off of the input cycle will get the current I, yes. During positive off will get we will write I equal to Im sin theta, where Im equal to Vm divided by RL plus small rf. Okay, the small rf here, the small rf is a new term. Vm is a peak voltage, 0 to maximum voltage, that is a peak voltage. Next, RL is a load resistance, and the small RF is a forward resistance of the diode, and we know the forward resistance of the diode is very less. Now we will see some of the important characteristics of half wave rectifier. Yes, first we will see the efficiency. Yes, efficiency of a half wave rectifier can define as output power divided by input power. As the input power, the total efficiency of half wave rectifier is M equal to 40.6%. And now next, second one is a ripple factor. We can define ripple factor as a amount of AC component present in rectified voltage. So rectified output are equal to 1.21. After rectification, there will be some amount of the component that will be present, that is known as the ripple factor. The ripple factor for a half wave rectifier is R equal 1.21. This means for each DC there will be 1:21 times AC component. Now the next one is a peak inverse voltage. Yes, peak inverse voltage, which is also known as a PIV. We can define as peak inverse voltage as maximum reverse voltage that can appear across the diode when the diode operating in reverse bias condition. We know that during positive off of the input cycle, diode was a forward bias, and during negative off of the input cycle diode will be a reverse bias. So during reverse bias condition was a peak voltage, it was Vm, so the maximum reverse voltage that can appear across the diode when the diode is connected in reverse bias condition is Vm. You can see this is a maximum reverse voltage, and that can appear. So across the diode, so we can write PIV means peak inverse voltage equal Vm. Yes, I hope you have understood of this topic. In this and the next lecture we will see the working of full wave rectifier. Thank you, and please do like, comment and subscribe.